I've got three functions for you to evaluate here. Sinh at natural log of 2, tanh at negative natural log of 5, and cosh at 2 natural log of 3. Generally speaking, if we're plugging in nice, neat integers to hyperbolic trig functions, we get messy answers. If we plug in natural logs or multiples of natural logs, things tend to simplify fairly nicely. We're going to get some fractions generally, but usually they'll simplify fairly nicely. So this first one, it's just a log. For the second, you've got a multiple of a log. Here it's -1 times the log, here it's 2 times the log. So see if you can remember how that works when you plug things into an exponential function. But basically what you're going to want to do is write these out in terms of the exponential function and then simplify. Go ahead and pause the video and give that a try. I have just reminded us up here of our formulas for sinh and cosh. Didn't bother to write out tanh, but I'll show you how I can use my knowledge of these two to remember tanh. Okay. So for sinh of natural log of 2, I'm just replacing the x's here with the natural log of 2. So it's e to the natural log of 2 minus e to the negative natural log of 2 all over 2. Now, I know e to the natural log of 2 simplifies to just 2. I just have to be careful here. A negative exponent does not make the result negative. It gives me the reciprocal. So this will be the reciprocal of e to the natural log of 2. So that's the reciprocal of 2 over 2. Now, that's a complex fraction. I'm just going to multiply top and bottom by 2. So when I do that, I get 4 minus 1 over 4. We get 3/4. All right, for tanh of the negative natural log of 5. Okay, what I'm going to do is first of all just write out the formula for tanh, but with open parentheses for the input. Now, I remember that tanh is sinh over cosh. So it's going to be this fraction divided by this fraction. I can see if I flip and multiply, the 2's will cancel. So I'm getting just the top of sinh over the top of cosh. Okay, so it's going to be e to a power minus e to the opposite of that power over e to a power plus e to the opposite of that power. And then what we're plugging in is the opposite of the natural log of 5. Okay, so here, the negative in the exponent tells me to take the reciprocal. The reciprocal of e to the natural log of 5 is just 5. Minus, now here the two negatives in the exponent position are going to cancel. So this is just e to the natural log of 5, and that's just 5. Here, e to the negative natural log of 5 is the reciprocal of 5. And then here, I'm just adding 5. Again, complex fraction, let's multiply by 1 in the form of 5/5. So that's going to give me 1 minus 25 over 1 plus 25. So that's going to give me negative 24 over 26. And I can reduce that to negative 12 over 13. Okay, excellent. So now cosh of 2 ln 3. So cosh was here, so that's going to be e to the 2 ln 3 plus e to the negative 2 ln 3 all over 2. So I need to remember, what am I doing when I have a multiple of the log? Okay, this is not going to be 6. I don't just evaluate e to the natural log of 3 and then multiply by 2. I say, I'll work it out over here. If I have e to the 2 natural log of 3, that's the same as e to the natural log of 3 times 2. I can multiply in either order, but that's e to the natural log of 3 squared. Because I know that when I have a power to a power, I would multiply the exponents. So if I see that in the exponent position I'm multiplying, I know I can interpret that as a power to a power. So if I take e to the natural log of 3 first, that's just 3, and then I can square that. So that's going to give me 9 plus, now that exponent is negative, so I'm getting the reciprocal of 9 all over 2. Let's clear the complex fraction by multiplying by 1 in the form of 9/9. So that's going to give me 81 plus 1 over 18. We get 82/18. All right, good stuff. So there will be times when you're working with these, there's some homework problems where you're just evaluating the functions, but often as we're working with them, you might have to, in the context of a problem, evaluate at some particular point. So good to just review how we evaluate, particularly at multiples of a log.